Hey guys, welcome to your Chapter 8 Lesson 4 notes on multiplying special cases of binomials. We're going to jump in and get started right away. In fact, let's get started with our example. Remember when you square something, that's multiplying it by itself. For example, 3 squared is 3 times 3, which is 9. So if we want to figure out what is x plus 8 squared, well, that's the same thing as x plus 8 times x plus 8. Now, as you remember from our previous lesson, we can distribute this. We can take, x plus 8, cool, and distribute him into x plus 8. That's one way. If you want to do that way, that's fine, and you can multiply that out, and that's great. I'm going to FOIL it, but we'll get the same answer anyway. So first, we get x squared. Outside, we get 8x. Move it down so we have some space. Inside, we get 8x. Oh, hey, twins. Twins. And outside, now I mean last. Last we get 8 times 8, which is 64. You know what, guys? I'm going to leave it as 8 squared. Okay, I'm going to show you why. So now that we've FOILed it out, oops, it's just too aggressive with my erasing. Notice what we have here. We have an x squared, and we have 2 times, I'm gonna rewrite them. 2 times x times 8 plus 8 squared. And this is the pattern I want to show you. Whenever you have something squared, whenever you have a square of a sum, so you have something plus something else, you can rewrite it like that. It will always take the pattern of the first item squared plus 2 of the first item times the second item plus the last item squared. It will always take that pattern. And that's our shortcut that we're going to do today. So if you have anything, no matter what your first item is, and you square a binomial, so you have 2 terms, 1, 2, added together to make a binomial, and you square it, that will always equal a squared plus 2 times them multiplied together plus b squared, forever and always. If you want me to prove it to you in class more than I just did, I would love to go over that proof with you. But for now, let's follow this pattern. In fact, you guys, let's really love this pattern. Okay? So here, to follow the pattern, let's first identify what is our a term and what is our b term. Here, our a term is 2m, and our b term is a negative 3. So wherever we have an a, we're going to put a 2m, and wherever we have a b, we're going to write negative 3. And now let's fill in what we didn't write. These guys are in parentheses, and they're squared. This is squared plus 2 times these plus this thing squared. Yoink. Okay. Now it's very important that you keep your negatives in line. This is not 2m minus 3, it's 2m times negative 3. This is not minus 3 squared, it's negative 3 squared. This is very important because zooming in on here, negative 3 times negative 3 is a positive 9. 2 times 2m times negative 3 is a negative 12m. And then 2m squared is the same thing as 2 squared times m squared, giving us a 4m squared. And that's it. That's our whole multiplied out product. 4m squared minus 12m plus 9. Wasn't that great? So not only did we used to have FOIL as a shortcut, now we have a shortcut to that shortcut, which is absolutely lovely. Cool. Here's a new shortcut for you. Yeah, I'll show you. I'll do an example and I'll show you what happens. Okay, so now we have two binomials and they're using the same numbers, but their signs are different. We have a plus and we have a minus. So let's FOIL it out and see what we get, right? Our first will give us an x squared. Our outside will give us a minus 9x. Our inside will give us a plus 9x. And our last guys will give us a minus 9 squared. I'm going to leave it like that. Because look, minus 9x plus 9x, they cancel each other out. Whoa. And all we're left with is x squared minus 9 squared. And that's kind of what we started with, right? We have x and a 9, and it's just the difference of their squares. It's just the difference of their squares. Check that out, okay? So that's our second shortcut. If you ever have two numbers multiply, so two binomials, and they're basically the same, but their signs are different, excuse me, then we call that the difference, subtraction, of the squares of those two numbers. So a plus b times a minus b is a squared minus b squared. And you guys, this is one of my personal favorite ones. I love it. It's so, like, such a simple product. Isn't that so cool? So this is our second shortcut of the day. Let's go ahead and put it to good use. Oh no, it doesn't match the pattern. Don't worry, multiplication is commutative, so we can rearrange these guys and it still works. Why are they such different sizes? Oh well, there's a quick fix for that. That's not that quick fix. Man, this was supposed to be the fast lesson. Yoink. Yoink. Good enough. Anyway, so here our our A term is x. And our B term is 8. So this will not factor out. That's the wrong way. X squared minus 8 squared is x squared minus 64. By all means, if you want to sit here and you want to factor it out, you want to FOIL it out, you want to first, outside, inside, great. You can do that every time and it will work. You want to distribute it out and get to x minus 8 times x plus 8 times x plus 8. That's great. That will 100% work. It will always get you back to x squared minus 64. So it doesn't matter which route you take. This one is the shortest way. Love. But whichever route you take, it will get you there. And that's fine. Oh, by the way, we didn't finish this problem. X squared minus 81. Yay. Okay. This guy. Hey, look. It still follows that same pattern, even though there are exponents involved. Even though there are exponents involved. Okay, and that's okay, even if it goes off the page. Oh well. Here our A term is x cubed, and our B term is 2. So that means our final answer is going to be whatever our A term is squared minus whatever our B term is squared. See, it's going to be the same thing. Wow, yay! Which is x cubed, that's a cubed, squared minus 2 squared. Well, x cubed squared, look at, we've got some exponents to multiply together. So cute. X to the 6 minus 2 squared is 4. That's it. Those are your shortcuts. Okay. So if you want to have them all in one place, that's great. You can totally do that. Where is a good place to have them all in one place? I know, down here in like our key idea spot. Brilliant. Who put that there? Seriously, guys, put these on your note cards. Love them forever. Straighten them so they go on your lines. Party. Well, whatever. And have a fantastic time on your homework.